My name is MIchał Okraska, and today I would show you something, a small presentation about laser patterning of rubber. First of all, a few words about technique. I used pulse laser, infrared pulse laser, which work in pulse when we have very short pulse. For this standard is 220 nanoseconds, and repetition of pulse is 27 microseconds. Laser beam dimension 23 micrometers. Beam speed on surface we can up to 15,000 millimeters per second, and we can module power of beam up to 20 watts. Standard frequency, standard pulse frequency is 36 kilohertz, but we can turn it up to 192 kilohertz. When we can change time pulse, frequency, and speed, and beam speed, and we can make different types of texture. Texturated places can put one on one or can be completely separated. What phenomena is in laser beam, and what happened when laser beam lay on rubber surface? Three phenomena is one is removing material by laser ablation. Part of material can be deposited on edge of crater, or some part of material can be transported by recoil. Laser beam generate heat on surface. Biggest advantages: it's very easy to use, fast, cheap, and waste-free technique. But surface have to absorption laser beam, and equipment cost is relative big. How fast is that method? You can see on short film. In less than 10 seconds, we've got four textures, 4 square centimeters, and in this sample we have 400 and 600 millimeter per second, and as I said before, we can turn it up to 15,000 millimeters per second. Few words about samples: matrix, EPDM, curing agent DCP, and 3 different pigments: black, brown, green, in 3 different content: 1, 2.5, and 5 PHR. Patterning mesh 0.2 millimeter, as you can see on slide. It's a standard commercial pigments, inorganic. And what is influence of the texturing speed? Every 3 samples takes the same energy in 1 millimeter of patterning. And you can see, unfortunately, the light when was taking a picture wasn't the same, but you can see the area, not patterning area, is quite same, and the white of pattern are similar. So the speed is not so much important, but now the same material takes different energy. Left side the biggest, right side the lowest, and in the middle, and one sample in the middle. When we have a big energy, this Virgin square is smaller, and the wide and deep of patterning is bigger. When we look on middle picture, we can see different shapes of patterning of patterning. When we comes to next slide, we have last pictures was from contactless profilometry, and here we have pictures from microscope, optical microscope, and in the same lower left the biggest energy, right the lowest energy, and we can see different spaces and places on left pictures have melted shape. So when we have pictures, maybe we can check wettability. And wettability we can say increase when patterning is made on the surface. It reference sample non-patterning, and the contact angle increase from 62 degrees to 136 degrees. Now I say some about colorant agents. I choose 3 different colorant agents: Mars black, chromite green-black hematite, and cobalt chromite green spinel. Here we have pictures how it looks, and these 3 types have different absorption of laser beam. Black one absorbed close to 90%, brown 35%, and green less than 10%. And when we have 3 samples, make it in the same conditions with different pigments, we can see difference between black, brown, and green samples, because on first and second we can see patterning, and in green one we see something happened on the surface, but it's not normal patterning. It's connected with this low absorption of laser beam. So I can make more tests and take different content of pigments. Brown pigments with 1, 2.5, and 5 PHR pigments in rubber, patterning in the same conditions, and we can see different depth of mesh, different depth of patterning. And next test, contact angle. For water, non-patterning, the same like last, 62 degrees, and it slightly increased to 132 degrees for 5 PHR. So when we have this two type information, we can connect it, the depth and quality of patterning with the contact angle, and this is the moment to quick conclusions. Deep and wide of texture mainly depend on amount of deposited energy, and amount of deposited energy depends on laser beam absorption of used colorant agent. And what you can see on last slide, contact angle can be connected with the texture quality. And in last thing, in next steps, I will trying different patterning meshes, because here I have square meshes, and I can make stripe or hexagonal, for example. Check different matrix, SBR and NBR, which second is now in progress. Still, I'm thinking about multi-layer composites and multi-layer textures, and I think I will use to check properties of these samples with micro hardness, friction, and infrared spectroscopy. So, thank you for your attention.
Thank you very much.